Hey, how's everyone doing? It is time for office hours. If you're here, drop those questions in the chat. We probably have some 201, some 320, some 475. If you have questions, let us know. What are those questions? Let me go look. What assignments do we have coming up in 320, 474, 475? So we got 320 right here. We got 201. We got 475. Let's see. If you have a question, drop it in the chat. Hey, James, good to see you. Happy Tuesday. Can we go for 1B activity 4? Of course. I'm not sure what output to use to determine the relationship. James, thank you so much for being here. Let me throw you some points, James. I would love some help with chapter 5, part 2. Maria put a question in the chat. You got it. So first question of the day is 320 related, BAS 320, and it is activity 4. Activity 4, question 1B. And the other one is Stat 201, and it's Chapter 5, Part 2. And drop a question in the chat. I was wondering if you could go over the question 3 of the homework Part 2. Awesome. So let me put that over here. Stat 201, Chapter 5, Part 2, Homework 3 question. Awesome. Let's do the 320 first. And if you mentioned a quiz question, I can do the quiz question. So tell me what the quiz question is. That way I will do said quiz question. And let's take a look. Little chill music right here. There we go. One of my favorite songs that we have on the playlist. All copyright-free music thanks to YouTube, allowing us to play songs right here. Activity 4. Where's that activity 4? Activity 4 quiz. Activity 4. Downloading activity 4. Downloading complete. There we go. Cassandra's got a question. So Maria, if you tell me which... Oh, I'd love some help on the yards question. The yards question. I didn't see that, Maria. Let me put that on here. The yards question. I think it's on the homework too. Reese says, I was wondering if you'd be able to use the applet on the test or not. What does the test look like? Who knows in the chat? I will throw 100 points if anyone knows what the test looks like. Such a great question, Reese. Thank you so much. Who knows what the test looks like as we hop over here to the activity? Who knows what the test is going to look like? Such a good question, Reese. What will the test look like? Let's hop over to the main screen. Here we go. Maria, thank you so much. 100 points in the chat right there. So when you're doing the Canvas content, you won't use the applet on the test. So the applet will not be used on the test. The test will look like the Canvas content. So as you do those Canvas content questions, make sure to be like, this is what the test is going to look like. Be like, this is what I will be doing on the test. So that's a great way to know what the test will look like. Canvas contents are your number one way to say, am I ready for the test? So Maria, thank you so much. So you won't use the applet on the test. It'll look like the Canvas content questions. Run the all correlations. I think this is the one right here, James, you were asking about. And put those questions in the chat, and we'll do as many as we can. We got an hour and a half, so we got this. We got activity 4, question 1B right here. Run all correlations on the entirety of the data frame to get the pairwise correlations between every quantitative variable. Add the argument sorted equals strength to have the list sorted by strength from most negative to most positive. What pair of quantities have the strongest, most negative, strongest positive, and strongest overall? Now, tool 1, this actually relates to you. You're welcome, Reese. Great job right there. Make Reese a mod right here. Why not? So this actually relates to tool 1. So if you're tool 1, you might say, talking about correlations right here. We were just doing that a moment ago. So let's talk about correlations right here. Now, who has a guess for 100 points? What do you think all correlations does? If I give all correlations a data set, what do you think the function all correlations will do? Watch this, you ready? What do you think all correlations finds for me? What do you think the function all correlations finds for me? Just take a wild guess. If I run this and I ask for all correlations, be like, the function's called all correlations, and I have a bunch of variables like height, weight, desired weight. You notice gender's not in here because gender's categorical. Shows all the right there, 100 points. It shows all the correlations. So it gives you every single correlation. And with 201, we were talking about correlation yesterday. We kind of alluded to it, that correlation can go from -1 to +1. That's the value of R. So what you're seeing right here when you see correlation, that's the value of R, which could be negative or could be positive. Maria, negative or positive correlation is just the what of the correlation. So sometimes correlation is positive, sometimes it's negative. That just indicates to you the what of the correlation. So if the correlation is positive or negative, that just tells you the what. So it wouldn't indicate strength because strength is closer to -1 or +1. If it's positive or negative, that would just indicate the what. The direction, Maria. Great practice right there. You see, there's all 322-1 crossover right here. So what we can do is we can sort this by strength. So sorted equals strength. And this is why I love coding, because now it gives us the same output. But notice that down here at the bottom, we have the correlations that are the strongest, most positive. And this is kind of obvious. There's a very strong correlation between someone's weight and what they want to weigh. Like people who weigh more generally want to weigh more. People who want to weigh more generally weigh more. Like there's a positive correlation. There's a negative correlation, if we go down here to the very far end of it, between how much somebody wants to weigh and their number of body piercings. We want to weigh less. Now we have something called a lurking variable. Can anyone guess? This is for later in this assignment too. What would be the lurking variable that might be part of the reason people who have more body piercings generally want to weigh less? And we're not saying this is true about the world. We're not saying this has to be this way. But generally speaking, people who have more body piercings generally want to weigh less. It doesn't mean you will. It's not cause and effect. It's just that generally, if you have more body piercings, generally you want to weigh less. Generally, if you have more body piercings, generally you're shorter. Generally, if you have more body piercings, generally you weigh less, and other variables. But these are the top 3 right here, most negative. So we would say for those who have more body piercings, we generally see that they want to weigh less. And the lurking variable, see if anyone knows it, would probably be, and we showed it yesterday, is gender. Because generally speaking, women want to weigh less than men. That's not true in all cases. But generally speaking, there's a relationship where females want to weigh less than males. And then there's also the relationship that generally speaking, females have more body piercings than males. So it becomes what we call a lurking variable. And just in case anyone's wondering, we can show this mathematically. So I'm going to show this mathematically. And we'd go here and we'd say, we want to explain how much somebody wants to weigh. And this is how statistics would look at it. We're going to use how many body piercings they have and their gender, or let's use their body piercings first. And this is the one variable model, y tilde x comma data equals. Oh, sure. Good. And so this is what we do in statistics, is we look at this and we say, oh, look, there's a statistically significant relationship between people's body piercings and how much they want to weigh. But if you add in gender right here, this is why gender is the lurking variable. Number of body piercings is no longer statistically significant. So the real variable that's doing the explaining right here would actually be gender. And this is multivariate statistics, where when we control for gender, you see that gender is actually doing the explaining. Where body piercings looked significant, it's actually gender that is significant in this model. And that's how we can show things to be statistically true, that it's not really awesome. Jackson helping out there, getting the David and Blaine up really quick. Jackson's from 100 points right there. So, not Reese, but trying to think who asked the question right here. Does this answer your question about what it's looking for, James? On activity 4, 1B, I'm not sure what output to use to determine the relationships. So the output we're going to look at right here is the all correlations. What we could do is we could store it into an object. So I'm going to store this into X. And if I want the most negative, I would say the head. Oh, there's the most negative because it takes the first 3, and here's the most positive. Oh, why do I keep doing 2? There we go. So here, let's just show only that output. That clears the output. There's the most negative and the most positive relationships. How's that looking right there, James? This is what we're looking for out of all the correlations. We've now found the most negative relationships between these, the 3 most negative, and the 3 most positive right here to talk about what are the strongest in terms of negative relationships. So would the strongest relationship be correct? This is the strongest. Now, you could view it in terms of strength by going to magnitude. You got to spell it properly. Magnitude. The question doesn't ask for this. But now when you view this, sorted by magnitude, and this is important to know, strength would be the correlation that is closest in absolute value to 1. So notice how some of these are negative, because when you talk about the magnitude of it, like how strong it is, like I know strength sounds like strength, but strength actually does from most negative to most positive. But strength of a correlation, like in terms of absolute strength, doesn't matter. Rock knows. It doesn't matter if it's positive or negative. It only matters how close it is to -1 or 1, or you could say 1 by absolute value. Does that make sense, James? Like this correlation is stronger than this one right here because it has a higher absolute value. So the strength of a correlation is how close it is to 1 or -1. And that is in terms of linear strength, because correlation only measures linear strength. Lots of little nuances to understand right here. So how's that looking, James? This is a different way of looking at it. This is not the current answer. You'd want to sort by strength and then look at the ends of the list to say these are the strongest negative correlations, these are the strongest positive correlations. But then we could look at it a different way and say, what are the strongest in terms of magnitude? And here's the weakest. And the weakest are the ones that are closest to 0. Doesn't matter that it's negative. It's just how close is this in terms of absolute value to 0. And that is the weakest. And then how high is it in close to 1 or -1? Doesn't matter if it's positive or negative. How are we looking, James, right here? Got it. Awesome work. 100 points. Let's head back to the main screen. Good review of correlation for every single class right there. There's a lot of crossover between 201 and 320. Even if we're coding, we're still doing some 201. And so I think Maria asked next the yards question. So we only have one more question after this. So we got a lot of time. Technically, this is only a 1 hour office hours, but you know, we go a little bit longer sometimes. Might have to make a call in a bit. But I'm gonna need more time than that to get the quiz up. So let's go grab that quiz right there. We had Calzone Tyrone visit us yesterday. He is a fan favorite. He attended our first Kahoot. And I looked in the chat, I was like, Calzone Tyrone. I was like, who is that? And he was like, I am a student from New York. I'm just checking this out. And he is just our fan favorite. It's sad because like a lot of people don't know about him. And I didn't have enough time to talk about him yesterday. I always mentioned who he is. That random student just decided to drop in and became part of our experience here. I love that. Okay, the yards question. I think they're both on the homework. So both of these are on the homework. The yards question. Here we go. Got the yards question up. And take a timestamp. There's one on the quiz. I think it's the same. Tell me, we'll do this one, Maria. And then tell me if it's different on the quiz, because I think it's on the quiz and the homework. Let's check this out. Here we go. Tell me if this is the one, Maria, right here. It says, in one season of a football league, the number of yards gained by each of the 158 wide receivers was recorded. A histogram of the data is shown to the right. The mean of it is this, with a standard deviation of this. Is this it? Yes or no? How are we doing? Is this the question you're looking for? There's a quiz version of it, too, which will follow the same pattern. So sometimes the homeworks appear on the quiz. You're like, ooh, it's a homework question. I can get this one right. Practiced it. Now, the first thing we should notice is there's a problem with this question. What is the problem you notice with this question? It says use the 68, 95, 99.7 rule. And what do you notice about this rule and this data? Yep. Good stuff. What do you notice about this rule and this data? What would you talk to me about this rule and this data? Like when you think about the 68, 95, 99.7 rule, what's a problem right here? Like, just talk to me about, like, well, wait a minute. You want to use the empirical rule for that data? You want to use the empirical rule? The 68, 95, 99.7 rule? This is not normal data. You say it perfectly, because now we should be using it for this. That's where we should use it. So, a little bit of a problem. So, it says according to the normal model, if the normal model was true. So, it's like according to the normal model, if the normal model is true. Like, let's pretend for a moment. Let's go to pretend world right here. Just use our imagination. If the normal model was true. So if the normal model was true, what percent of receivers would receive fewer than 2 standard deviations? So let's draw a little sketch right here. And let's go down 2 standard deviations. So the first question is, what percent are between -2 and 2? So what percent, I did a horrible drawing today. What percent are between -2 and 2? So Maria, what percent are between, according to the normal model and the empirical rule, what percent would be between -2 and 2? So according to the empirical rule on the normal model, what percent would be between -2 and 2? So that's the first question. We'll find the answer here to the full thing in a moment, because it wants below -2 and 2. But what percent is between? So it wants below 2 standard deviations. 95, exactly. So this is 95 right here. It doesn't want this, though. It wants this. So now we need to do the outside trick where we go here. So Maria, what is the answer going to be for this area right here? Like this area right here is what percent of the data? So it's 95 between -2 and 2 according to the 68, 95, 99.7 rule. Those are numbers we need to memorize. We often show them on the test too, but so you have to understand that means between -2 and 2 standard deviations. If you go out that far on the curve, we would expect 95% of the data to be contained in there. And so what is that shaded area then? And then how would we find that? Well, what we would do, and I'll see, we'll get some answers right here. Oh, yeah. So it's saying assuming normal, 100 points. Maria's got it right there. Maria's like, oh, I see it. So we would subtract from 100 the 95%. I don't know how to spell 95. We'd subtract from 100 the 95%, and then we would go right here and divide it by 2 because it's on equal sides. So Maria has found the 2.5 according to the normal model. So according to the normal model, it would be 2.5. And that's just how we find that area, according to the normal model. And this is not what it is. It's just according to the normal model, if the normal model was applicable. Now, this question is a bit interesting, but let's just think about where 2 standard deviations is down. If we go to the mean and subtract 2 standard deviations, where would we be at? So here's the mean, and let's go down 2 standard deviations. Here's the first standard deviation down, subtract 1 standard deviation, and subtract 2 standard deviations. We're at -315. What do you know? Some receivers would be gaining less than this. If the normal model was applicable, then this would be true. And our data doesn't even show that. So if this is the true model right here, we should expect to see some receivers getting less than -315 yards. 2.5% of them would, according to the normal model. So that doesn't sound applicable to me. And we might have... Oh, so why is the issue? A, B, C, D, E. Maria, you got this. I'm going to start a song right here. Maria, A, B, C, or D, or E. What do you think? What do you think was the problem right here? You got this. 100 points on the line. You got this. What do you think's the problem? Like, we just went the wrong way on this problem. We shouldn't have been doing that. The problem's like, you got it. It is right skew. Right to the high. Left to the low. What are we talking about? We're talking about that Monster Man's tail. There he is, Mr. Monster Man. And there's his tail. Monster Man's tail is on the high side today. There's the low side of the data. Right to the high, left to the low, whatever the Monster Man's tail goes. That's how we do it. There we go. Excellent work, Maria. That should be another 100. No wrong answers today. And I think we're doing this one next. Maybe we'll find out. Here we go. Wrong button. When I click the button, I look over and get things ready. And I'm like, okay, click the button. Do the thing. Oh, wait, that was homework question 3. Maybe we'll do this one right here. We need more questions. I should put up the question thing. Say Brian's taking questions. Why do I have a Discord thing? Why do I like Discord window? I don't even know. Brian is taking questions. Ask away. Questions thing is up with more questions. Cinderlands. Oh, yeah, I'll stop doing that. I shouldn't do that. I'm just clicking random buttons on my screen. I'll stop. All right, let me do another question right here. We'll do one for fun. Okay, so we just did that. Homework question 3. We just did it. So drop more questions in the chat if you got them. 201, Chapter 5, Part 2. Homework question 4. So let's check this out here. Here we go. This is one of my top favorite questions of all time because you would think you need the applet, but you kind of do. You kind of do. And so in Pearson, if it does not say use empirical, then do we actually calculate? This one requires you to calculate. It is highly suggested to have the applet open while doing this, but what you should know without the applet is you should know the pictures for all these. So we're going to pretend for a moment we don't have the applet, and we're going to see how well we could do without the applet. Then we're going to redo this with the applet. So Maria, drop more questions if you have them. I'm just kind of doing my own thing for a moment since we don't have that many questions right now, but drop more questions if you got them. The first thing says right here, we need to find the area above a z-score of 0.95. 0.95 would be on the right side of the curve because it's above 0. Remember, the center of the curve is where 0 is at, and then 0.95 would be above the center of the curve, and we're shading greater than it. This would be the area right here. Let's check the answer. Now, if we use the empirical rule, 68 would be between 1 and -1. 16% would be outside. And so at this point right here, like if I were to go to right here, above here is 16%. So this means this is a little bit more than 16, a little bit. Because right here at 1, according to the empirical rule, 68, 32, 16, 16 over here, we would have a little bit more than 16 because this right here is a little bit more than where 1 would be at. It's a little to the greater than it. So we can take some guesses at this and maybe get it. Oh, no. We're taking guesses. These are all guesses. Oh, no. It does build up a little bit quickly, doesn't it? My first guess was really close. I think I guessed like 17.11 or 17.21. 17.11 is the answer. Close. Close. We gave some good guesses, so we got close. About 17. I should have just said 17. I wonder if that would have gotten it right. The next one, though, I have more faith in. The next one says less than 1.95. 1.95 is on the right side of the curve, and we need to go less than it. First thing you want to do if you look at this, so you always want to be able to draw these out and make an educated guess of what it is. You don't have to be perfect. You should think this is a lot of the curve. You might be thinking, is it 95, 96, 97? But here's the thing. Above 2 is 2.5% of the area. So this is going to be a little bit more than 97.5, or a little bit less, excuse me. So with the knowledge that it's a little bit less than 97.5 using Pearl, James, you got it. We'll do one next. With the knowledge of it being a little bit less than 97.5, we got it. We were able to accurately guess that one. Oh, we'll do the IQR one. You got it, Maria. And we're just doing a little bit of fun. We do use the applet for this. I've done the applet one. This is very hard to guess between these areas. So between these areas would be right here, and this is a very hard one to guess. Watch me get it. It's going to be closest to this. And we're just doing a guessing to show we have knowledge of how to kind of guess at these. Oh, I forgot my guesses. And we can come back and actually do this one. I was close. I said 88%. It's 87. That's a very hard one to guess because it's not near the numbers. This is the area outside of 1.6. And so it'd be right here. And 1.6, let me think real quick, because I know some extra numbers you don't know. You're not meant to solve these like this, but you're meant to take a decent guess. This is definitely less than 32, but more than 5%. It's also going to be between, oh my gosh, my brain's breaking, 20 to 10%, but closer to 10%. So it's going to be, no. Yeah. Okay. 12.11. Nope. I'm probably going to be way off on this one. It's going to be closer to 13, isn't it? Sure. 10. I should have just guessed. I was closer with my 11% guesses. So we'll come back. We can redo this question a little bit later, but that was guessing through it, and we were able to guess some of them accurately. I think we guessed close. We got one guess right, but we were able to identify the pictures, and please use the David M. Lane applet to solve these, but you should have at least an understanding or a close guess. If you look at all our guesses, we were off by 1% there. We got that one correct. We were off by 1% here, and we were off by 2% there. So that was our worst guesses. I was trying to go a little bit quicker. But make sure to use the applet. I do this in other videos, and we can come back here. If you're in the video and you're like, how do I solve that with the applet? We'll come back here and do it with the applet solve if you like. But we got some additional questions. So check out the other videos if you want to watch the applet solve, or swing by and say, hey, Brian, just solve this one. Do it with the applet. That's how I want to do it because I want to get the right answers. Let's go back. So in person, it doesn't, yep. And then so James asks about another one from the activity 1D. We're asked to make a scatter plot and determine whether you use Spearman or Pearson to gauge strength. Let's go take a look at that. Okay, 1D. Okay, so which one are we graphing here? Rerun the all correlations. Oh, wait. The analysis you've done so far assumes that Pearson coefficient correlation provides a suitable measure of the strength of the relationship. This may not be the case. Rerun the all correlations command from part B, but add the argument type equals Spearman so that Spearman rank correlation is considered. So are you talking about 1D? Wait, so... Oh, wait, here it is. You're talking about this right here. Okay, make a scatter plot of their relationship. Okay, here we go. So gotta pull up something right here. Gotta get the notes from yesterday. 2 seconds. I closed my Word documents, so I lost my Word documents. We got 4 people watching. Love it. Okay. So we're going to bring up a review thing I wrote yesterday. Okay, here we go. Let's take a note of what time we're at. Okay, so time is BAS 320, activity 4, question 1D, Spearman versus Pearson. Okay, let's go check this out. Okay, so I've got the video up from yesterday to kind of give some guides. I can just overlap myself right here. Whoa, there we go. Perfect overlap. And so with this, wearing my Cardinal shirt yesterday. Whoop, whoop. And so with this, there's some important things to know about Pearson versus Spearman, James. Anytime we talk about Pearson or Spearman, we must ask some important questions right here. Pearson is mainly meant for what? When you read through these notes right here, James, Pearson is mainly meant for what? It must be this. We got a requirement down below down here. What is required of Pearson? These are great notes to have. Got some color coding showing what's going on here. What is a really good thing for Pearson to have? Pearson must have this. Like if you say Pearson, you're like, it's got to be this. If we're talking Pearson, it's got to be this. So no matter what, if you say Pearson, and you can see I drew like the part of the P of it with that right there, it's got to be linear. Great job, James, right there. It's got to be linear. Now, so what do you think of this as a counter? So if you think about Spearman, Spearman could be nonlinear. Now, that's not a requirement. It's not required to be nonlinear, but linear is a requirement for Pearson. It has to be linear. So we say QQ straight enough, no outliers in 201. And look, QQ, 2 quantitative variables, straight enough, no outliers, plot doesn't thicken. A little bit of 201 right there, review. But when you think about what Spearman does, it's almost a response to what Pearson can't handle. Where Pearson is linear, Spearman can be nonlinear. Where Pearson has no outliers, or else it's going to be pulled towards the outliers, Spearman can handle the outliers. Where Pearson has homoscedasticity, and do you know what homoscedasticity means, James? Like, feel free to let me know. I'll explain here while we talk about it. This is homoscedasticity in the yellow right here. And could break it down to 2 words where it's heteroscedastic or heteroscedasticity. What it means is same spread, like same thickness, same scedasticity, thickness throughout. Just ignore that P part of the P. It's maybe we're just looking at this right here, the scatter points. And heteroscedasticity means differing thickness. So hetero meaning different. Heteroscedastic relationship will change in its spread. Doesn't have to get thicker, as we say, the plot thickening. But a heteroscedastic relationship. You want the same thickness. If you're doing Pearson, you want homoscedastic. Thus, the response which Spearman can handle is heteroscedastic. Now, what is required of, and so I'm going to ask the trick question here. What is required of Spearman? All Spearman relationships need to be this. What is required of Spearman relationships? Like if you're like, let's look at Spearman. You would say, I need it to be a this relationship. If we look at Spearman, you would say, it's got to be a this, though. Like where Pearson has to be linear, Spearman needs to be this mostly. Like mostly linear for Pearson, mostly this for, and then we'll talk about what that means. Mostly this for Spearman. Like if you're like, okay, we have Spearman, it needs to be mostly this. Doesn't need to be 100%, but mostly. The requirement, Pretty much. And that's what monotonic means. Mono, one, tonic, direction. So the data goes generally up or generally down. Monotonic. Yeah, and you can say it without the word, which is good too. So we might say it needs to be generally going up or generally going down. It can't be non-monotonic. So which of these should we use for this sort of graph right here? Should I use Spearman or Pearson? It's a trick question, so watch out. Should I use Spearman or Pearson for this? Is it linear? That's a requirement for Pearson. Is it monotonic? That's a requirement for Spearman. So James, what do you think we should do for this data right here? Would it be good to use Spearman or Pearson? What do you think? What do you think? And then let me ask you, what are the two variables that we're looking at the relation for? I can't remember from yesterday. Can't remember the two variables. So what do you think for that data set right there? It's not following a line, and it's also not monotonic. Correct. Breaks the requirements for both, so no to both. Both are a bad idea. I mean, that's the simple answer. It's like both are a bad idea. It doesn't meet the requirements for either. It's not linear. It's not monotonic. So really, neither one of them is a good idea. The way stats goes, sometimes you say, well, both are a bad idea. So with that, you just say we don't have a good Pearson or Spearman's not a good way to describe that relationship. We might have other ways with like parabolic forms. And I might be able to find where we did 1D to remember the question. Do you remember, what are your two variables you're doing? What are the two variables you're doing for this? Because I think this is where we did it. And I talk about how to calculate Spearman right here. So I give like a mini lecture on it. The two variables, here we go. Desired weight and number of body piercings. Is that the two variables? It looks to be. Desired weight and number of body piercings, I think. Yeah, I think so. Okay, let's go check it out. So the associate function, so we're doing survey 10. Let me do this. Attach survey 10. This is how you get autocompletes. And let's go associate desired weight tilde number, and I'm only getting autocompletes because I have done the attach. Data equals survey 10. And now let's take a look. And I'm noticing some issues right here immediately. What issues are you noticing right here, James? What do you see? I'll graph the issues for you. I didn't do this yesterday, so this kind of adds to it. I'm seeing this. And I see this. What are maybe some key issues right here? So what have I highlighted in yellow? Which is at least one of those. And then what am I highlighting in the blue bands? So I'd say there's two issues right here. Also, we might say there's also this. Maybe some sort of this. Yeah, we could talk about some visualization for you bet. Yeah. Let me put visualization number 4. Yeah, pivot charts. I think that's, we don't, did Marie ask one? I think Marie had a question. IQR. IQR cholesterols. That's next. So chapter 5, part 2, cholesterol question. Cholesterol levels. Outlier in the plot thickness, the heteroscedastic, yeah. Heteroscedasticity, heteroscedastic. So there's nonlinearity with the red line showing the nonlinearity. The blue bands show the heteroscedastic relationship, and the yellow outlier. When I took classes with Dr. Seaver, we always had to graph these and draw on the graphics to show what's going on. So I've been in the practice of, highlighting these for a long time to show, like, we have an outlier by the yellow dot. We have a blue bands showing the plot getting thinner, showing a strength in the relationship increase. And one thing I do want to point out is we could actually take a look at the lack of linearity, which you're not meant to know this yet, but we can see if there's non-linearity to this. Let me go to max order equals 2, and you can really see that there is a non-linear pull to this. You're not meant to know these things yet, but if you look at the data and you kind of see, if you go through the center of it, that it would bend, it might even have a higher polynomial order. I could look at some of the diagnostic statistics over here, and frankly, it looks to have some polynomial order to this. Like, it would be better to bend through the data than to put a line through the data. The line has problems that the line doesn't go through the majority of the data, especially at the end. If you look at the line you would fit to this data would be very bad at the end, and we can show that by just showing the line to show how bad the line does at the end. So you're not really meant to do that yet, but you're kind of meant to think, would you have to draw a line through this, or would you draw a curved line? So this is the best way to be like, what would I do? Then we could actually have the software do it for us, and we could see what those curved lines would look like. And some of these look similar to what I drew when you think about that blue line there, looks similar-esque to what I drew. It's kind of a going through more the center of the data, and my red line looks like that blue line a little bit. It curves up at the end because it tries to go back through the data. So in truth, mine should go back up here at the end, and then I've basically drawn one of the higher polynomial relationships, which is more true to the data than the line itself. So the answer is there's some nonlinearity, there's some heteroscedasticity, and I think you said it a little while ago, James. This would be Spearman or Pearson. Which one would we use? Due to all the issues in this, should I use Spearman or Pearson? What do you think? Due to all those issues with that plot, should I be using Spearman or Pearson with the plot we just talked about? So the one we just did, yeah, this is going to be a Spearman. With all the issues we see, that is going to be a Spearman. It's got a nonlinear relationship. It's got outliers. I did them in different colors. I should have done the exact same colors here. But it's got, oh, Maria, no worries, no worries. This is a more advanced way to do correlation. And we're just going to focus on Pearson for our class, which is linear. I don't see a monotonic. Oh, James, you get 100 points right there. Maybe. It's a very small region. It's a very, very small region. Since I drew that is monotonic issue. It's a very small region, so I don't know if I'm going to say the whole thing is a monotonic issue. But James, you are correct. The end of it right there does not follow the monotonic pattern. How big of an issue is that? I think the heteroscedasticity is a bigger issue. The nonlinearity is a bigger issue. There might be some lack of monotonic relationship in this. The end of it is a very small, it's a very small portion of the data, still exists. But great job right there earning that 100 points. That is not going in one direction, which is non-monotonic. And then if that was the only issue, I'd be like, use Pearson. But coupled with all the other issues, I'm seeing that it's a problem. Great job, James. Excellent work. I was like, does it have non-monotonic? It does. So we got some IQR stuff coming up right here with the cattle. Wilson's one here. IQR of cattle. Now, what does the IQR represent? While we're getting the question ready here, I want you to think about what is the IQR. As Ren Hoek once said, what is it, man? What is the IQR? Should put that on the soundboard. What is the IQR? What does it mean? The IQR stands for the interquartile range. So the IQR is the interquartile range. Q3 minus Q1, yeah. So how far are those numbers away, Maria? Great answers, Maria. 100 points, Maria. How far are those numbers away? Middle 50%. And so using that information is really going to help us with this question. I'm getting it loaded up here. Thank you, Maria, all these answers. Love it. We're going to use that information right there, the middle 50%, to help us answer this. I'm trying to find the question. Here, I'll show you. Oh, getting close. No, we passed it. So it's the middle 50%. We know that. There's the Z-score one again. We did that one. We did this one. Downhill skiing. Middle 40%. Kind of the same. All right, here we go. No, this is steers, which is the same concept. But let's find the cholesterols. Where is that? Trace, good to see you here. Trevor, excuse me, Trevor. Looking for cholesterol. Where is that cholesterol question? The Forrester is at it again. I'm in part 2, yes, I am. What up, Troy? Good to see you here, Troy. About to the we found it. Let's do this. Cholesterol question, here we go. 4021. Drop those questions in the chat. And let's go take a look at this. So we're going to use the normal model to describe the data. At the center of the normal model is the mean. The mean is going to be the value right there at the center that doesn't help us narrow down any of these curves. The standard deviation of 21 is the units by which we go up and down each time. What do I mean by that? I mean, if you're here at the mean of 182, you would go up by a standard deviation of 21. You can see it right there. If I move it, it'll move back. So we need to go up by 21, and this is the only one that does it. This one goes up by too little. That one goes up by too much. This one has a consistent increase from 182 up each time by 21. You go up 21, up 21, up 21, down 21, down 21, down 21. This will be the right answer. So when you look at this, we can kind of guesstimate some answers again right here, but the first thing you're going to want to do is go over to actually have the ace that, yes, that is awesome, David. 100 points, ace in that canvas content. So we're going to go over here to David and Melaine applet. Or did I say David or Troy? Troy, great job right there. Let's head over here. We got the David and Melaine applet open. So you want to open up the David and Melaine applet right now if you're working this problem. And once again, we will show you questions on the test that might show you pictures of the applet. So this is a good way of like getting practice right here. What percent of adults do you expect to have over 200 milligrams per deciliter? I think that's what that is, of cholesterol. Well, let's go over here and put in our mean of 182 and our standard deviation of 21. I'm actually going to go to the other curve and also put in mean of 182 and standard deviation of 21. So the first curve allows us to put in values of cholesterol and find the amounts above, below, between, or outside those values. So we need to be here on the first curve when it says what percent would we expect over 200. It's going to be about right here, so maybe about 17-ish percent, 18.2, 19.57. Well, sometimes you're a little closer than other times. So that is the percent, and it's a little bit more than 16 because 16 is above one standard deviation via the empirical rule. We cannot use the empirical rule to solve this, but we could get estimates from the empirical rule to say it's got to be more than 16%, but less than 50. What percent of adults do you expect to have cholesterol levels between? So we need to click the between button, 160 to 170. Now that's about here to over here. Well, there's 34% in here, and it's the smaller side of it. So that's going to be about 12%. I just like to guess these for fun. Oh, make sure you type in the numbers correct. 12. I said 12. It's that. Decent guess. Not as close as I'd like to be with my guesses. But there we go. Now here's where people might get stuck, which is all right. It now says the middle 50%. So you could go in and make some guesses and figure out what the middle 50% is. But the easiest way to do this is go over to this one and ask, well, I want the middle 50%. And so Maria, oops, I said 60. We want middle 50. Maria, what should I do to these numbers right here to find the IQR? Now this is Q1 to Q3. Oh, you got this, Maria. Our talk conversation on it, Maria's got it right there. So we want to go right here and just take these two values and subtract them to find their distance. So great job, Maria. As we talk through it, it's like, okay, wait, I see it. This whole chapter is like a you see it or you don't chapter. And I think that's the toughest part, is it can be very frustrating. Wait, I didn't do every question. What did I not do? Oh. Above what value are the highest 15% of adults? Well, we need to do the same thing. Go over here to highest 15%. And the highest 15% would be over here. So make sure to be graphing the highest 15%, not the lowest. Who knows in the chat for another 100 points? The highest 15% is what percentile? So the highest 15% would also be the what percentile? What? Oh, I'm submitting the quiz. The highest 15% would also be known as the what percentile on this graphic. So the highest 15% would be also known as the what percentile on this graphic. So rather than calling it the highest 15%, I could also say the 85th. Maria, great job. And that's good understandings to have, that it's the 85th percentile because 85% is below the highest 15%. Understandings like that will help with the test. If we ever ask where is a certain percentile on the curve, you could then take guesses. And I probably could have guessed it's a little bit higher than 203. I probably could have guessed that one, but we did some guessing earlier and we had some fun with that. But now we did the actual question. Let's talk a little bit about visualization number 4. Let's go over it here. Okay, so some visualization number 4, and we've got open questions. I don't know why that little thing keeps coming up. Maybe I just want to play that song. I don't know. Let's go check out some visualization number 4. Sorry, buddy. I will sleep one of these days. Oh. Doing some visualization number 4. And we have open questions. So drop the questions in the chat. Pivot charts. I need to update this for all my classes. Okay. You're welcome, Maria. See you tomorrow. Let's over to the main screen. So if you're watching this video right now, we will be doing a full video on this on Friday, a full walkthrough. So make sure to check out the Friday session where I do a full walkthrough of visualization number 4 and join in live if you want. So you might be watching this now. We're going to do a kind of just medium talk on this, but if you're here, ask the questions when you got them. So we have right here an Excel data set. Use the file stat201 surveydata.xlsx to create the pivot files chart. See the below for the details about the requirements for each pivot chart. There are helpful videos on the Stats1 YouTube channel. Woo! Display average weekly hours worked, differences by gender, separated by if students have loans. Create a pivot chart of your choosing, and so you need to make sure you create one of your choosing right here. So what I'm going to do is I'm going to work with a data set that you don't have to make one of my choosing that does pivot chart number 2. So we need to basically then do a write-up, make sure to do all this. You'll notice right here all the grading. Always look at this to see how you'll be graded. I know it's a lot, but as you go through here, awesome. Great job, Maria. Awesome work. So I'm going to do like the second one, but I'm going to use a data set you don't have. So that way I can kind of do my own work and you can kind of follow along. So let me go grab that data set real quick. 2 seconds right here while I get some data. Okay, so let me go to R. And so got class in a little bit. So write.csv and survey 10 survey.csv. Okay, cool. And survey.csv. Okay, we got it. I think I've got the data. I'm just getting a data set you don't have so I can work problems or like do things that other people won't be able to like create exactly the same thing of. So this is a data set that I'm using. You will not be using it. I don't think it says for yours to use the data set you're choosing. You're going to use the data set right here. So download this data set. I think it'll open properly. Yeah. And so this data set is now opening on the computer right here. I'll show, keep enable editing. Cool. Okay, cool. So you'll be using this data set right here. This is your data set, but I'm going to be using this data set. Does that make sense, Maria, right here? Like you're going to use this data set over here, which has gender, age, born in Tennessee. I'm using a different data set just so I'm not doing the same work, like the exact same work. I don't want to like have somebody just like follow along and do the exact same thing I do, but I'm going to be showing how to make the pivot charts right here and like what to do when making them. So I'm going to basically make a pivot chart and explain it and kind of do like the second one and you should get something that looks like this. So yours will look like this to a certain degree. So we'll be covering pivot charts on Monday. I'm making a video for this on Friday and I'm moving our assignments to Tuesday if you're in my class. I want to do it in this order right here because chapter 5 was such a big one. I kind of introduced it earlier and we took some extra time with it. It is a very tough chapter that takes a lot of practice. So I want everyone who's working hard on chapter 5 to get it. I'm just gonna get choked up right here. 2 seconds. I am back now. But I want everyone to take the time on chapter 5, and then pivot charts is not the hardest one. So with this said, here's how we make a pivot chart. First, click Control or Command A inside the data. So have that data downloaded right there. Click Control or Command A inside the data. Next, go here to Insert and go to Pivot Table. See, I thought we were going to make a pivot chart, Brian. Just wait. Make sure you're working in Excel, and I highly recommend to be using the Excel downloaded. So you can get Excel for free through UT. Make sure to go into the apps on the Outlook. If you need help with this, let us know. But I highly suggest to be downloading and having Excel on your computer. Just doesn't hurt to have it. That way you don't have to worry about being online, using the apps. And you want to be using Excel on your computer right here. Good stuff to go. So we're going to go ahead and click the Pivot Table button. And we're just going to click OK. There's options here, but we've selected our data. So let's just click OK. So with the data currently selected, and let me disappear, we need to put in certain variables. Now, the number one thing we need to talk about first is the value. The value is what you're displaying. So maybe I want to look at how many video games are people playing? Like weekly hours of video games is what I want to understand. So the first thing you need to know is the values. The values is what we're trying to understand, and it's the first question we usually talk about. You can't really make a pivot table or chart without displaying values. I want to look at hours of video games. So what do we get here first? This is the sum of hours of video games. Like from all the students, weekly hours of video games sum up to 1,721.577. Well, let's make some changes to this. I don't want to look at the sum. If you click right here on Mac, it'll be a little I symbol and go to value field setting. That is the setting by which we display the value. The value has a setting for it. So let's change the setting and make it so we're not looking at, and we'll zoom in on this so everyone can see. We're not looking at the sum. Instead, we want to look at, let's say, the average amount of video games people are playing. So let's click right here. And now we have the average. But I want to point something out. This is not a good way to display something. This right here looks all crazy. Now, maybe we want that amount of accuracy. Maybe someone's like, I want it to as many digits as you can show me. Personally, I wouldn't want this. Once you click this number and do it at this stage, I'll tell you why I do it at this stage. It'll carry through to remaining stages. Click on this number right here and then go to home. On home, click the delete decimals button or decrease decimals. It's not going to delete them. It's just going to decrease and round. Maybe you want it to 1 decimal. Maybe you want it to 2, maybe 3. If you notice where I'm kind of going, I think an average might be to 2 decimals for average weekly hour video games. That's kind of good right there. That is good. So once you've got this formatted, you've got it on the mean, and you've got it to the decimal formatting you desire, now we can start to divide it up by other variables. Let's go take a look right here and divide by other variables and choose something like, let's go here to gender. And we're going to just put gender in either the rows or the columns. Rock knows.
It doesn't matter.
We'll just pick one. So now you can see, on average, the males right here are playing more video games than females. And so maybe there's another variable. We don't have a lot to choose from in this data set. Let's say significant other. Whoa, I'm interested in that. Here, let's find out. Okay. Oh, whoa. So here we see something different right here. This is pretty interesting. So you won't have this data right here, but take a look. The people who are playing the most video games on average are males without significant others. And what's weird is when males have significant others, we see a decrease in their video games. Still a lot of video games. I mean, I'm probably increasing that right there too. I play a bunch of video games. And so I have a significant other. I play a ton of video games. So I do not follow the trend in the data. And then also what's weird to me is the females follow the different relationship where females who have significant others play slightly more video games. So we just see this in the data right here that females generally play less video games than males. Now, that doesn't mean all males play video games. That doesn't mean all females don't play video games. These are generalities, because if we were to go here and look at the max for each group, I wonder what we'll see. Let's go to value field settings. Let's say the max. Let's look at the top individuals. There we go. Look at this. 30 hours right there. That's a gamer. So 30 hours right there. So definitely you can't say everybody. Don't make generalizations based on trends and data. It's just generally we see this. I know that's what sounds like a generalization, but then don't extract that to individuals. Say, oh, you would be this because of this. No. My fiance plays a ton of video games and she's female. So you've got right here, and also she's dating me, so we're like engaged to me. So she doesn't follow the trend right there, and probably we both play more video games. We've been playing It Takes Two lately. Really great game there. Check out It Takes Two, about a relationship. So we can't generalize to individuals, but we could talk about trends and data. And so we're going to change this back here to average. So you see there's a lot of options, but now we have the averages for each group. Now this is not, once again, saying every individual is just on average. Males who are not dating people do not have a significant other, males who do have a significant other, females who do not have a significant other, females who do have a significant other. It's really limited. What's really cool about this is you can change it very quickly from a different variable to ask, like, how about people's GPAs? And you see, we don't want the sum of people's GPAs. We'd want something like the average of people's GPAs. And the people with the highest GPAs are the females. And it really doesn't matter if people have significant others. The differences here are just really male-female differences. You can just drop any variable you want to analyze and say, like, let's look at tattoos. And now that's the sum of tattoos. Let's look at the average amount of tattoos. And we do see a little bit of differences. Little males, when they're in a relationship, ooh, there's some relationship difference right here going on. People in relationships are more likely to have tattoos. Interesting. That's actually just as big as a jump from males to females in tattoo differences. So I don't know. Why is it when maybe you're getting that tattoo for that relationship or something? I don't know. Pretty interesting data, but it is kind of low. That's, very small differences. Not a lot of people have tattoos, at least according to this data. But pretty interesting to look at that right there. This might be let's look at piercing still. I don't know. I just love looking at data. If you can't tell, it's just fun to like take something right here. Piercings are going to be mainly those differences right there. It looks to mainly just be male-female differences. Any other fun ones? How about how people rate their own attractiveness? This is a rating people gave to their own attractiveness. Let's see any differences here. Males who are in relationships think they think they are the best looking out of everybody. So pretty interesting right here. People in relationships sometimes find themselves to be more attractive when they rate their own attractiveness. Okay, one last one. Let's look at how funny people think they are. And here's how people think how funny they think they are. The people who think they're the funniest are males who are not in relationships. There you go. They think they're the funniest people. Not really a big difference here between the males there. Not big difference between the females. It's mainly male-female differences right there. But pretty interesting to look at the data. If you can't tell, I just find this fun. I just find it fun to go through here and grab different things. When you look at things like GPA, you can see the differences right here and what they're attributed to. Just make sure this makes sense when you're talking about it. Now that we have something we might want to visualize, all we have to do is go here to Pivot Table Analyze and go to Pivot Chart. So we've got our table the way we want it. And let's go to Pivot Table Analyze and go to Pivot Chart. And then we're actually going to select this first option right here. There's lots of other options. Be careful. You could select something a little interesting. We're going to select this first option right here. And here's how we can do it really quick and really easily. We're going to move this over here to the side a little bit. And then we're going to click over here to Design. And then we're going to go to Quick Layout. And we'll go to this. This is one of my favorite quick layouts. It's only missing one thing. It's missing an axis title down here. So let's click the plus icon. On a Mac, it'll be, maybe I should go where the Mac's going to have it. It's going to be over here. So on a Mac, you will have to click over here. So the PC has this option. I don't know why the Mac doesn't. On a Mac, you will have to click under there, under Design. Watch the tabs where I'm at. Be very careful. You have to click the chart for the tab to appear, and they have to go to Design and go to Chart Elements, Axis Title, and make sure both primary and vertical and horizontal axis titles are on. From here, we just need to make it look really pretty. And so I'm going to zoom out a little bit, kind of increase and make this look good right here. And we would say average GPA by gender and relationship status prepared by Brian Stevens. Axis title right here is gender. And then over here is average GPA. And there's our screenshot. From here, we just need to take a nice pretty screenshot. And there's our previous graphic. We don't need those up there. Let's not take those. You can copy paste into Excel, but I like to screenshot it to create a static object. I'm going to work with that static object then. Go to a new document and drop it in here and talk about this. Maria, how's it looking? Are you able to get to this point right here where you've got a cool, nice looking graphic? And then we just need to talk about what we see. Mention the values. 1, mention the values. 2, mention key differences between groups. Mention values. Maybe mention lowest and highest groups. Mention relationships. 5, mention values. What do you think is very important while doing this, Maria? Right here, when you're doing your write-up, what is going to be very important, which a lot of people just fail to do? It drives me crazy. I'm pretty quick on grading stuff nowadays when I have to grade. If I see you don't mention values, ooh, not good, not good. If I see you're like, looks like females are higher than males, I'm like, well, yeah, that's true. I mean, it's a true statement. How much higher? Can you subtract the difference? The highest group right here were females who do not have significant others with a GPA of 3.26, where the females who do have a significant other were virtually identical with a GPA of 3.25. The males had a vast difference between the females, where the males who do not have a significant other were 0.24 lower than their female counterparts, the ones we can compare them to right there, where the males with no significant others had a GPA of 3.02. Very similar difference also for the males that do have significant others with a GPA of 3.03, which is 2.22 lower than the females who do have a significant other. In general, the males are around 0.2 of a point lower than the females, or around, I don't know, 0.24 lower than the females in general. And so you want to talk about what you're seeing right here. There doesn't look to be differences on whether or not someone has a significant other. I would say that, like, the differences between significant others are just 1/100th of a point between both groups. It doesn't look to me like that is that big of a difference. It looks the difference mainly look to be between the males and the females in this survey. That is what we are communicating to people. Notice how I was constantly mentioning values. I'm talking about these differences I see right here, these differences I see right here when you compare across, but mention the values. Like, if I can't state that enough, like, you want to be like saying a value and saying what it means to you. Is this important? Does this sound like something we should care about? And that's what we need to be doing as we go through the data. Well, that's a good segment right there on how to do pivot charts and pivot tables. And if you understand what the filters are and everything, all the different fields right here, I should say fields because there is a filter field, you understand what you're creating. So the big thing with pivot tables and pivot charts is to understand how to make them, understand what we would add to them, and understand how to read them. This little 15-20 minute lecture right here we just did on it covers everything that we'll cover during the lecture. So it's not meant to be that complicated. It's like pivot tables analyze data for us, categorical or quantitative, and we can make lots of really good graphics. With that, these office hours technically end at 2 p.m. and I need to make a call or two. So I'm going to end office hours, but I will be back later for afternoon office hours. So Puppet Shark, you going to be back? Yeah. Puppet Shark will be back. We will be back here in a little bit for some afternoon office hours. Swing back by with questions if you got them. We'll do more office hours. I'll see everyone in a bit. Bye for now.